continuing with the first case where the lowest priority group can be on the plane but up, let's now take the enantiomer of the example that we took before. So this is exactly what we took before. If we take the mirror image of this, so it's like if we place a mirror plane in front of this, then we would get something like this. So this is number 1, this is number 4. Clearly the mirror image would have 3 and 4 in these positions. So 1, 2, 3, 4. So now the exercise is, in order to determine the absolute configuration, is to view the molecule so that the lowest priority group is away from us or completely behind. And again, to do this, we need to look here actually away from, that's the eye. That's the eye. So that's exactly the way of looking at the molecule, is completely opposite to the lowest priority group. If we do that, what do we get? Now, if we do this, okay, so we get something like this. Let's show this with models. So something like this. So this is the lowest priority group, the group number 4. This is 1, this is 2, and that's 3. So 4, 1, 2, 3. So 1, 2, 3, 4. This is on the plane up, the lowest priority group. This is this group number 1, which is also on the plane, but these two groups are outside the plane. What we need to do is we need to look at the molecule so that the lowest priority group is away from us. So this is actually the direction of sight, if you like. So opposite to the lowest priority group. If we do that, we can actually rotate this to achieve something like this, so that the group number 4 is not actually visible or is not actually seen by you as a viewer. So what do you see? You see actually 1, and here 2, and here 3. So 1, 2, 3. Remember again, that's number 4, that's number 1. You look from here. If you look from here, so it's like this basically. So 1, 2, 3. 1, 2, 3, and it is of course clockwise rotation, and therefore this clockwise rotation is given this descriptor or description of R, and it is R. So this is an R absolute configuration. So this is exactly what's obtained. So that's 1, 2. This is 1, and this is 3. Remember, 4 is actually behind. It's like, again, the steering. When you drive a car, it's like a steering wheel. Okay, the rod which connects the steering wheel with the rest of the car at the back. That's the group number 4. It's not visible, of course. So that's exactly the idea of this, is to view the molecule so that the lowest priority group is at the back or away from us as viewers. Now we have 1, 2, 3. If it is 1, 2, 3, this is clockwise rotation, and therefore it is R. It is R because the rotation that we obtain now is clockwise, and it should be R because the absolute configuration of this, as we determined before, this is actually S, and this is of course now R. They should be opposite in absolute configuration. So this is actually logical. That should be the only difference between enantiomers, is the absolute configuration. So this is the way to go if we have the lowest priority group on the plane up.